Hi, it's Eden. Today I'm going to be doing problem 4B from the exam. This is take number 2. I just did one run and it was like 20 minutes long, so I'm going to try and do it a little bit faster this time. So we have this series 2x minus 1 to the n times 5 to the n root n, and we need to find the interval of convergence for this power series. So as soon as I hear that, I know that I need to perform the ratio test and make sure that that is less than 1, and then the interval of convergence will be the result of that ratio test from -1 to 1, and I'll see what those two numbers are, and then we'll check the endpoints. Okay, so for the ratio test, we're going to determine this is b to the n, and then what is b to the n plus 1. So b to the n plus 1 equals 2x minus 1 to the n plus 1 over 5 to the n plus 1 root n plus 1. And so for the ratio test, we're going to take b to the n plus 1 over b to the n, absolute value, take the limit to infinity. So limit as n approaches infinity, absolute value. And to speed things up, I'm not going to do the whole b to the n plus 1 over b to the n. I'm just going to rearrange the terms. So take this bottom portion, put it up to the top, and then take the reciprocal. So 2x minus 1 to the n plus 1 over 2x minus 1 to the n multiplied by the reciprocal, which is 5n root n over 5n plus 1 root n plus 1. Okay? So I just skipped a couple steps, but hopefully you can see that I just flipped it there. And so now I can cancel out some of these terms. So since I have an n plus 1 over n, I just keep the constant from this term, which is 2x minus 1. And then same thing here, I just leave the 1/5 since n plus 1 is in the denominator, and the n's stay the same. I can't really touch those. Okay, so let's rewrite that. This is the limit n approaches infinity of 2x minus 1. This is still an absolute value times 1/5 times root n over root n plus 1. Okay. And so now I can actually take these out of the absolute value because they're a root. So that absolute value doesn't really apply to them anymore. We'll just leave these constants and then try and take the limit of these n terms. So instead of doing L'Hopital's, I'm going to multiply it by 1 over n, because I think that'll simplify it for taking the limit. So 1 over n, 1 over n. And then also, since it's a square root over a square root, I can just make this whole term a square root. So let me rewrite that over here. So I have the limit n approaches infinity of absolute value 2x minus 1 over 5 times big square root n over n is 1. Actually, I'm just going to leave it as an n right now and then take the limit. I think it'll just be easier to see. So n over n over n times 1 over n. So we know that these terms are 1, obviously, but I'm going to take the limit right now. So limit of 1 is 1, limit of that is 1. And 1 over infinity is 0, so we know that this entire term is just a 1. Square root of 1 is 1. So the limit of this series is simply just 2x minus 1 over 5. This whole thing disappears, becomes a 1, multiplies to here. So I'll just write that out. That is equal to 2x minus 1 over 5. Now to complete the ratio test, I need to confirm that this is less than 1. So I'm going to create an inequality where this is less than -1. Yeah, it needs to be greater than -1 and less than 1. And so these two values will give us our interval of convergence. Okay, so multiply by 5, multiply by 5. This is -5. 2x minus 1, 5. Add 1 to both sides. Plus 1, plus 1, plus 1, negative 4. Okay, divide by 2. Alright, so my proposed interval of convergence is going to be, let's see, negative 2. And then this is 3. Okay? So I don't know for sure if these are going to be included in the interval or not. Right now I'm proposing that they're not until I check the actual values. So let's see. I'm going to take negative 2 and plug it into the original series and see what we get. So let's check negative 2. So we get equals 1. Negative 2 times 2 is negative 4 minus 1, negative 5 to the n over 5n root n. Okay, I can simplify this, cancel out the two 5s. That leaves me with negative 1 to the n over root n. Now this is very obviously an alternating series due to the negative 1 to the n. So in order to determine if negative 2 is convergent here, we're going to need to perform the alternating series test. So we're going to confirm that this is less than the n plus 1 version. That's going to tell us that this is decreasing, and then we also need to make sure that the limit goes to 0. Okay, so let's set up that inequality. So we have 1 over root n is greater than 1 over root n plus 1. Alright, so cross multiply both sides. Root n plus 1 is greater than root n. I'm going to square both sides. N plus 1 greater than n. Alright, subtract the n. So 1 is greater than 0. So this series is decreasing. Now let's take the limit to make sure that the limit approaches 0. So, alright, where are my notes? Yes, okay. So I'm just going to take the limit of this right here without the alternating part. So limit n approaches 0, infinity approaches infinity of 1 over root n. Well, square root of infinity is infinity, 1 over infinity is 0, so that passes the alternating series test. So this is officially convergent at negative 2, so we can change that to a square bracket to include negative 2 in our interval of convergence. Okay? Let's see. Let's do the same for 3. Okay, 3. So 2 times 3 is 6 minus 1, which is 5. Okay, so this is 5 to the n over 5n root n. Alright, same deal as last time, 5's cancel. So that gives me, well, that'll give me a 1 to the n, but 1 to any power is just 1. So this is going to give me, whoa, that's really bad. Okay, this is going to give me 1 over root n. Yeah, 1 over root n. And so if I rewrite this as I learned in Calc 1, square root is equal to 1/2. So this actually looks like a p series where p is equal to 1/2. But we know by the p series test that it needs to be greater than 1 for it to converge. 1/2 is officially less than 1, so we know that this is actually going to diverge by the p-series test because 1/2 is less than 1. So 3 is not included in our interval of convergence. So this here is our official interval of convergence for this series right here. Thank you.